Example 1. Identify the period, amplitude, phase shift, and midline of f of x equals 2 sine 3x plus 1. So the numbers we have in here are 2, which is the amplitude, 3, which is omega, or the number of cycles in 2 pi, and b, which is up 1. Okay, so first thing I'd like to do is find the period. So we can do that by taking 2 pi, which is the period of the fundamental cycle, and then we divide that by omega, 3, the number of cycles in 2 pi. And that gives us a period of 2 pi thirds. So then if we want to find our quarter marks for that, we split this 2 pi thirds into quarters. So half of it would be 2 pi 6, which is pi thirds. And then half of that would be pi twelfths here. No, half of pi thirds would be pi 6. Pi 6 here, and then this would be another increment of pi 6. How many would that be? 3? No. This would be 1 pi 6, 3 pi 6, 2 pi 6, 3 pi 6. So that is 3 pi 6. That's at pi halves, right? And then 2 pi thirds for the end. So I don't know if that made any sense. So these pink lines here are my quarter marks. Let's talk about that. Oh, the smaller line here. So these are quarter marks. And what that means is we're putting a point at every quarter of the period of this graph. So we found the period by taking 2 pi over omega, which we talked about, right? So 2 pi over 3, because omega is 3. So that means that this quarter mark is at 2 pi thirds. This one is at 0, because we're not moving left or right on this problem. And even if we were moving left or right, we would probably do that very last. I think moving the phase shift is like one of the last things I would do. Have everything else intact and then just move it. Okay, so then half of 2 pi thirds is, halving the thirds would be 6, so that would be 2 pi 6, which is also pi thirds, right? So then this quarter mark would be at pi 6, and this one would be at 3 pi 6, so we have like 0, pi 6, 2 pi 6, 3 pi 6, 4 pi 6, but of course our 2 pi 6 reduces to pi thirds, and our 3 pi 6 reduces to pi halves. And so that's where our quarter marks are. What's important about the quarter marks? Well, that's where our intercepts, or minimums and maximums will go, right? So we have an intercept, maximum, intercept, minimum, intercept. Then we have an amplitude of 2. Normally I would kind of do that amplitude before I do the move upward. So kind of have like our graph down here first at those key points, right? Before, and our amplitude would be at 2, so we've got that maximum value at 2 and that minimum value at -2. So then we can just take our midline and the entire graph and move the whole thing up 1, shift it up 1. Fortunately, this one has no phase shift. Hopefully, graphing with the quarter marks like that makes sense. Okay, let's look at the next one, example 2. So, I don't know if you understand, but if you were to correlate this with the textbook, this would be example 1 for the details, and then example 5 for graphing it. And I've just put those together. Okay, example 2. Maybe we should just kind of delete this one and start fresh. Grab this. Control X. Okay, and then I'm just going to get rid of everything in here. So clear all this out with this button. I've still got those lines that I'm using for my quarter marks, but that's okay. Alright, here we go. Fresh start. We have A, but it's reflected, right? And then we have omega. And then this is our phi value. I don't know how to draw phi. Is it like, that's not right. let's go back and look at phi. Oh, that's how I usually draw, with a circle and a line through it. Okay. Thank you for letting me remind myself of that. So we have phi. I certainly didn't get that through the middle. Oh well. So one thing we have to pay attention on this particular problem is that omega is not 1. And we also have a phase shift. So the first thing we'll want to do is take out that omega so that we can see we have, I guess that should be a 2. And then we have x minus the phase shift, well, x minus pi, but the phase shift is actually pi halves because we factored out that omega 2, right? And this one doesn't have a vertical shift. Whew, thank goodness. All right, let's go ahead and find things. So period. So omega is 2. So for the period, we just take 2 pi and we divide by omega. So 2 pi divided by 2, and then reduce it. So that's at pi. Our amplitude, remember, is always a positive number. So this would be 3. Phase shift. So the phase shift is going to be to the right, because it's minus. To the right, pi halves. And then the midline is just that. Part's easy because there's no vertical shift. So y equals 0. Okay, so I found those things. So that's example 2. So then if you go forward to example 6 in the book, you have where you put the graph together. We're going to start by doing the quarter marks. So right now, all that's marked in here is the edges. We've got 0 and pi. So that's the edges of one cycle of our graph, right? So if we wanted to, we could put some quarter marks in here. Let me grab this. Actually, before I do that, I'm going to paste this thing for later. I'll use that later so I don't have to redraw it. Okay, so I'm going to grab this, copy one of these little things. So let me, there's one. I'm going to put one at half. And then one at pi fourths, I guess, would be about there. And then one at 3 pi fourths. So about right there. So there's my quarter marks. So then the graph itself would be an amplitude of 3. I drew this previously. Let's see if we can put that into place. At least sort of. So starts down here. So normally our cosine graph starts at positive 3, but because this has a negative, we start it down here at negative 3. And then it goes up to an y-intercept at the corner mark, a maximum at the half mark, x-intercept, sorry, I said that wrong before, at the third quarter mark, and then back down to the minimum at the end. So the reason that these are down here instead of up here is because of the negative 3, and I've put the amplitude in there and everything, right? So notice how I graph this with the correct period and the correct amplitude before I do any shifting at all. So if I were you, I would graph it in stages, like make a light line of this or use some colored pencils to distinguish between the phases. Okay, so now this one is going to move to the right pi halves. Well, our quarter marks are at pi fourths, correct? So to move this to the right pi halves, that means that each of our, oh, I didn't mean to do that. That means that each of our quarter marks right here at pi fourths, pi halves, 3 pi fourths, etc. So this point right here is going to move a whole half to over here, right? And this point here is going to move a whole half to over here. This point here is going to move a whole half to over here. And this point, an entire pi halves to about here. And then this point to an entire pi halves about here. Moving our entire graph, let me grab this again, Control V. So moving that entire graph to the right pi halves. We've still maintained the same period, we've still maintained the same amplitude, we've just moved it. And I'm going to go ahead now and shrink this little sketch down to something that's less visible. Maybe I'll just make it kind of transparent, so just a little bit of a guideline is all. And this is our actual graph.